In this video, you'll learn about data integration. In particular, you'll see how to combine very different data types, such as images and categorical features. We already mentioned that it's not a very good idea to just throw in image data alongside sensor readings and categorical features. Now we're going to talk about why. Let's go back to our agricultural application from Course 1. Farmer Betty has images from her drone and moisture readings from the field. Remember that images contain hundreds or thousands of pixels. Although we think of this as two features, the image and the moisture readings, the machine doesn't see it that way. The image is a list of hundreds or thousands of pixel values. If we combine it with a single moisture reading, we're implying that each individual pixel is just as important as that reading. Individual pixels really aren't that meaningful. So our machine learning algorithm is being given a whole lot of noisy features that aren't necessarily relevant. Remember that this makes the learning problem harder and means we'll need more data to compensate. In our example, Betty used the images as input to a growth stage classification QAM, and then used that classification as a feature for the fertilizer QAM. Another possibility would be to use unsupervised learning on the images and use cluster membership along with the moisture reading. Cluster membership might be a useful feature whether or not it maps exactly to classes like growth stage that humans would pick. Classic computer vision techniques also provide a path to convert images to useful features. Although individual pixel values are not usually super informative, you can construct features from them that might be. One example is scale invariant feature transforms, or SIFT features, which is a publicly available tool. Deep convolutional neural nets like ImageNet may be all the rage these days if you have a lot of data like Google does, but SIFT features can provide a useful boost when you have limited data. Another way combining data may create problems is when values have drastically different ranges. Betty has data with different ranges. For example, temperature, soil pH, and moisture reading all have different units and scales. She wants to combine them with a binary signal like growth stage or cluster membership. The machine learning system can handle this variation, but evening out the ranges through normalization can improve learning speed. You'll learn more about normalization techniques in a later video. So in this video, you learned about how to use some multimodal data as learning data in a machine learning process. Sometimes you get different data types like images, numbers, and binary signals, and it might be hard to combine different kinds of data in order to effectively use them as the learning data. Part of the machine learning process is considering what transformation steps are required, and knowing what your data actually means in your problem domain helps you know what transformation steps are most important.